All right, guys, in this video, we're talking about arc length for parametric defined equations. So if you're looking at this one, this is just arc length for a normal function. So this would be arc length from some interval a to b. It was a square root of 1 plus the derivative squared. So that's arc length in normal rectangular form, but now in our parametric form, because it's got an x and a y going on, the arc length will be very similar. It's the integral from a to b. Those are going to be t numbers. The integral of x prime of t squared plus y prime of t squared. And it's the integral with respect to t. So just one of those things you have to memorize, but if you have the other one memorized, then this one should be pretty straightforward. So the arc length, that is very similar, and they'll ask you sometimes, like if a function is defined or if some particle is moving defined by a parametric equation, what is the total distance traveled? That's the same thing as finding the arc length. Also, one little note, when you're doing arc length, like if I'm trying to find the arc or the length of that distance traveled, I can't include it. I don't want to make sure I don't want to include like if it goes 2 times around. So we'll just be careful that doesn't like go over itself. Yeah, that'll be something we come up to later. All right, find the arc length of the curve defined parametrically by the x is t cubed plus 2. The y is 2 times t to the 9/2 on the interval from 1 to 3. So pretty simple. We need to find the derivative of the x component, which would be 3t squared. The derivative of the y component, which would be, 9 over 2 times 2 would be 9. Subtract 1 from the exponent. So our arc length, which is a formula you put on your memory sheet, and you just remember this, is the arc length is the interval from 1 to 3 of the square root of the x prime term squared plus the y prime term squared with respect to t. So I need to do this one without a calculator. So this one would be the square root of 9t to the 4th plus 81t to the, what would that be, 7th power? Oh, are you serious? Okay. Doing this again. So I'm going to come up with that last thing I wrote, just square root of 9t to the 4th plus 81t to the 7th. Okay, so from here, I'm going to, this is hard to integrate, so I'm going to factor out 9t to the 4th, leaving me with 1 plus 9t to the power of 3 dt. I'm integrating this. Actually, I'm not going to integrate yet. I'm going to take the square root of each part. So L would be equal to 1/3. The square root of 9t4 is 3t squared. Keep the square root of 1 plus 9t cubed. And I'm going to use some u substitution here. So u is equal to 1 plus 9t cubed. du would be equal to 27t squared dt. So I'm going to rewrite this as L is equal to the integral from 1 to 3, but that's in terms of t. I'm going to change this in terms of u. So plug in that lower limit of integration, plug in 1 for the t, so 1 cubed times 9 plus 1 is 10. Plug in 3 cubed is 27, times 9 is 243 plus 1, 244. And then, okay, so du is 27t squared. So t squared is here in the du, square root of u. But instead of 3, we multiply by the reciprocal of 27, so 1/27. So the 3 over 27 would reduce to, was that 1/9? And I'll put that in front. So this would be equal to the integral of 1/9 u to the 1/2 du, add 1 to the exponent, multiply by the reciprocal, There's already a 1/9 there. Plug in 10, plug in 244. So what is this going to be? 2/27 times 244 to the 3/2 minus 10 to the 3/2. And we're gonna just safe stop there. All right, so what this represents is the arc length or the distance traveled by something defined by this parametric function for time interval 1 to 3. All right, next one. All right, so this is a good one. So if x is cosine and y is sine, if you graph this, so if you have a calculator, change your mode to parametric mode. If you graph sine, or you graph cosine of t as your x component, sine of t as your y component, and you graph it, you're gonna get a circle. And if I change the window, and I made the t max 2 pi, it gives me one full circle. And if I make the t max equal to pi, it would draw 1/2 circle. So it makes exactly one revolution, and we kind of know that, from 0 to 2 pi. All right, so x prime of t is equal to negative sine. Y prime of t is equal to cosine. The arc length, the distance traveled from 0 to 2 pi, is the square root of the derivative of x squared, which would be sine squared t, plus the derivative of y prime, so that'd be cosine squared of t dt. Now I've got to know that identity, that sine squared plus cosine squared is equal to 1. So it's just the square root of 1 dt. The antiderivative of 1 is, with respect to t, would be t. You evaluate it from 0 to 2 pi, which would be 2 pi minus 0, which is 2 pi. So that's the distance traveled of that parametric equation. All right, let's see. I only have 2 more, we're done. Okay, let's just go and do it. All right, so same thing, find the distance traveled by the parametric equation. X prime is equal to -4, y prime is equal to 7 on the integral, so L is equal to the integral from 0 to 2 of the x prime squared would be 16, y prime squared is 49. Okay, that's just a number, but if I integrate a constant, I would get that constant in front of t. You evaluate from 0 to 2. Plug in 2, I get 2 square roots of 65. That is the distance traveled, or the arc length of that parametric curve from 0 to 2. All right, last one. A particle moving along the curve in the xy plane is defined parametrically, but this time they already give us the derivatives, and it's calculator active. Find the distance traveled by the particle on the time interval from 1 to 2. So in my calculator, I'm going to type, math number 9, integral from 1 to 2, and I'll just plug this in. So the derivative of x, so I'll put parentheses around this, this is tangent inverse. I press second, and then tangent on the calculator is tangent inverse of e to the negative t, and then close parentheses, square it, plus the derivative of y, which is given to us, square that. And when I plug this into the calculator, it gives me 0.40662. Pretty straightforward. So main thing about today, arc length, distance traveled by a parametric curve. You gotta memorize this formula. Other than that, pretty straightforward. Thanks for watching. Hopefully this helped. Bye.